So our objective for today is to be able to identify polynomials by both their degree as well as the number of terms. And as we continue looking at this section, we're also going to be able to describe the shapes of their graphs. You're going to be able to describe if the function is even or odd, and we're going to describe its end behavior. So by the end of this unit, you should be able to roughly sketch a graph of a polynomial function based on all of that key information. So let's start with some vocabulary. A monomial is a real number, a variable, or the product of a real number and one or more variables with, and here's the key idea, and we kind of talked about this the other day, whole number exponents. So a square root, a cube root, etc., those are fractional exponents. Therefore, they are not polynomials. A monomial can have no denominator and is one term. So what you should notice is that there are no mathematical operations with a monomial. There's no adding or subtracting. In math and in physics, you will also often hear us use the word constant. A constant is a monomial with no variables. A constant is a monomial with no variables. So the number 13 is a constant where 3x, 4y squared, and negative 2xy are monomials. So 13 is a constant, and then the other three are examples of monomials. So that takes us into our next word, which is coefficient. A coefficient is the numerical factor in a monomial. A coefficient is the numerical factor in a monomial. So x has a coefficient of 1, negative 2t has a coefficient of negative 2, negative ab has a coefficient of negative 1, and this one is a little trickier. That's a coefficient of negative 1/3.
Please excuse this interruption. At this time, would any senior who has not yet had their individual portrait taken for the yearbook please report to the field house? Again, any senior who has not had their picture taken for the yearbook, please report to the field house. Thank you.
The degree of a monomial is the sum of the exponents of its variable. So we talked about that briefly at the beginning of chapter 6. The degree of a monomial is the sum of the exponents of its variable. X squared yz has a degree 4. A non-zero constant like 13 has a degree 0. A polynomial is thus the sum of more terms that are monomials. poly means many. A polynomial is the sum of one or more terms that are monomials, where poly means many. They are classified by the number of terms they contain and their degree. Standard form of a polynomial is the arranging of the terms in the polynomial in descending order. A one-variable polynomial in standard form has no two terms with the same degree. A one-variable polynomial in standard form has no two terms with the same degree. A binomial is a polynomial with two terms, or the sum of two monomials. The word bi means two. So you can think of a bicycle, binomial. They all have that prefix of bi, where bi means two. Bivariate data. That's where numbers and data are only represented by 0 and 1. A trinomial is a polynomial with three terms. It is the sum of three monomials, where tri means three. You can also think of the word tri as a prefix in other words we know, such as triangle or tricycle. Not pronounced as tri, but triplets. If we have a single variable polynomial, then we oftentimes also classify it using the following terminology. We can also do it with multi-variables, but you consistently see these words and terminologies being used when you have a single variable. So let's just talk through them. If the degree is 0, then we call it a constant. If the degree is 0, it is a constant. If the degree is 1, then it is linear. A linear function can have no more than two terms if it is a single variable, because you have the linear term and the constant term. We just finished Chapter 5. Chapter 5 was all about quadratics. Quadratics are polynomials with degree 2. They look like U's. We're going to expand that knowledge, and we might have some cubics. Cubic functions have the highest power, degree 3. A quartic has a highest power, degree 4. A quintic is our highest degree polynomial with a special name. It is degree 5. And then anything greater than 5 is known as the nth degree. So anything greater than 5 is known as the nth degree. So like if the highest power degree was 7, then you'd say it's a 7th degree. So that's what I mean by the nth degree. Okay, so let's classify some polynomials. So in those first two examples, what you need to recognize is that they are not in the correct order and that we have like terms. So the first thing you want to do is rearrange the terms so that they are in descending degree. So that is known as standard form. And simplify. So you're going to write them in descending degree and or simplify. Those are the first steps you would do on 1 and 2. That would then allow you to classify them. So in number 1, you have a quintic trinomial because it's degree 5 and has 3 terms. So when you classify them, you're classifying in 2 ways, by degree and number of terms. In number 2, we have a quartic binomial because we have 2 terms with degree 4 is the highest power. Okay, so in example number 3, we have 3 terms. You have to find the powers and sum them together for each term individually. So this is degree 3, 7, and 6. Now you don't add all of those degrees together to get the degree of the polynomial. You simply look at the largest. So this is a 7th degree trinomial. Try for 3 monomial terms being added or subtracted. This 13 is a constant, degree 1, degree 1. So this is a linear trinomial. And then in number 5, we have degree 3, degree 4, degree 4. Therefore, it is a quartic trinomial. So I told you that we'd be able to classify polynomials in a few ways. One way was by their looking at a function and knowing its degree and number of terms. The second classification is going to come from looking at a graph. So if you have a horizontal line, that's degree 0. It is a constant monomial. So you actually have to draw in that horizontal line on your page. It didn't copy over, or if it did, it's super duper light. So make sure on your first graph you get that horizontal line and label it a constant monomial. The second graph represents degree 1, that is linear. The next graph is a parabola, that's degree 2. It's a quadratic. The third graph is cubic. The number of zeros also tells us the degree. So a quadratic could hit at most 2 times, making it degree 2. A cubic can hit at most 3 times. A quartic can hit at most 4 times. And a quintic can hit at most 5 times. Okay, I want you to look at the degrees that are even and the degrees that are odd, and tell me if there's anything you notice about the 2 graphs on the left that's different from the 2 graphs on the right. Good, cool? Yeah. Awesome. So even both end in the same direction, either both up or both down.
There is a red Ford Escape in the back parking lot with its radio and lights on.
Someone didn't turn their car off today. And then in the second example, like Cole mentioned, they're going in opposite directions. So odds are opposites, evens are together. So that leads into what I think is maybe the first new thing for us today, which is end behavior. So I gave you this totally filled in chart. This chart is going to be super helpful for you. So If they're even n degree, then they're going to be in the same direction as they are in that chart. Odds are going to be an opposite. And then you also need to look at the leading coefficient. So the leading coefficient is the first term on the highest power degree. So let's just talk through the vocab for a second. The domain of a polynomial function is always all real numbers. Ingrain that in your brain. The domain of a polynomial function is always all real numbers.
Please excuse this interruption. At this time, would all members of the class of 2021 please report to the field house for your picture. Again, all members of the class of 2021, please report to the field house for your class picture. Thank you.
We are going to be classifying polynomials by degree and leading coefficient. And that's where I was saying this chart's coming into play. So you're going to look at degree and leading coefficient. And then we're going to be making little charts that look like these, as f of x is going to positive infinity, f of x is going to negative infinity, and so on and so forth. So the easiest way to do that is to just look at some graphs. Here is the same statement, but everything kind of put into even versus odd. Even degrees will have an even number of real zeros or no real zeros. The end behavior is always in the same direction. Odd degree functions will have an odd number of degrees and an opposite end behavior. Sorry about that. You're good now? Is everybody okay for this slide as well? Okay. Yeah, sorry guys, I know today has a lot of vocab writing. So let's look at this graph. So it says, for the graph, describe the end behavior. So what you should notice immediately looking at the graph is that they go in the same direction. So that tells me that this is an even function. So it says determine whether it's an even or an odd. It's going to be even because they're in the same direction. And then it has no real zeros because it never hits the x-axis. And this is how we write out end behavior. As x is getting big, so x is going to infinity. So that's me drawing along this line right here. What are the y values doing? Well, the y values are going down to negative infinity. So instead of writing y, we have that notation f of x. This is just proper function notation. So f of x is kind of representative of y, but we do it with function notation. Because if you had multiple graphs on here, then you wanted to describe this graph. So by labeling it with function notation, you describe that particular graph. As x is going to negative infinity, so that's the x's going to the left. Where are my y values going? Well, the graph is going down, so my y values are going to negative infinity. This is probably the most new thing for you, is that function and behavior notation. So that's what this is for describing the end behavior. So once again, looking at this graph and just the graph, I know this is degree 3 because it crosses once and then has another max and min. So the degree is one more than the number of max and mins. The degree of a function is determined by one more than the number of max and mins. So if I have total of 2 max and mins, degree 3. If you have a total of 5 max and mins, degree 6. The end behavior. So again, as x goes to infinity, where's my y values going? They're going up. So f of x goes to infinity. As x is going to negative infinity, my y values are going down to negative infinity. This would be an odd degree, and we actually can know the degree. It's degree 3. And then talking about the number of real zeros, the number of zeros has to sum to the degree. So there's 1 real 0. And then if we actually knew this function, you could factor it and you'd get 2 complex zeros, which are our i's. So you would get 2 I answers and 1 real answer for this graph. So it's sort of like everything coming back together in 6-3. So what you're going to do today is the classifying the polynomials, which is the naming 1 to 14. And then you're going to do the next page, which is very similar to what we just looked at the end, which is describing end behavior, even or odd, and number of zeros. So that's that next 2 pages in your packet.